So today we'll just do a very brief lecture over how to make an R Markdown document. And so what I have is RStudio open, but I don't have anything in the upper left. I'm just going to go, so there's this file new icon, but if you go to the arrow just to the right of that and click, there's a lot of other things you can do inside of RStudio. We introduced this at the beginning of the semester, but mostly just focused on R scripts. But today I want to show you R Markdown. And so I'm just going to click on this R Markdown. And I want you to notice that there's a pop-up window that comes up. So it says new R Markdown. It could be a document, a presentation, a Shiny app for the web, or we could create something from a template, but we're just going to stick with the default document. We can change the title of this document. I'm just going to change it to R Markdown example. And then I'll just put the author, I'll just put my information there for the moment. And then the default output. So the idea of an R Markdown document is that you can show embedded within a single document your code, the output from your code, and then you can embed even graphics, and I'll show you how to do that, or figures within the document. And you can create a PDF or a Word document that basically you could then share with collaborators or maybe a future version of yourself that just shows everything in one consolidated document that is much more widely shareable than the R scripts that we've been using in this class, okay? Certainly HTML and PDF can be opened on a lot of machines without having proprietary software like the Microsoft Office suite, which would include Word. What I recommend is just use HTML as the default. You can knit it. I'll show you what that means in a minute, but you can convert it into a PDF or Word later, okay? But HTML is the easiest to work with, so we're just going to leave that HTML, and I'm going to select OK. And what it does then is it creates in our upper left editing window here, instead of an R script, it's this RMD untitled one, okay? And RMD stands for R Markdown. It gives you the title, the author, it automatically puts in the date, and then it tells the default output is HTML, okay? Then what I want you to notice is that there's this embedded code, okay? So there's these three kind of backwards ticks there. The curly brackets, where if you put the word or the letter R in there in lowercase, it will interpret that as a chunk of R code. You can code other things like Python in here. It doesn't have to be R, but we're going to focus on R. And then there's some default options that are here. But basically what that means is there's a little bit of code that's embedded there within this document. But then we close it. That's what line 10 in this example is showing. It closes that chunk of code, and that's what it uses this term CHUNK to represent chunks of code or little bits of code that are embedded within the document. So we close that chunk, and then we're back outside of R, and this is where we can start to put text into the document. And here there's two pound signs or number signs or hashtags, a space, and that space in this case is important. In R, when we're coding, usually spaces don't matter when we're within an R script, but in an R Markdown, the two hashtags and then a space means that any text that comes after that is going to be a second level heading, okay? And you can make a larger heading by using a single pound sign, or a second level by doing 2, and then a third level by doing 3, okay? And this is a little bit different than what we've been doing when we annotate code using the hashtag. That just means that it's annotated text, but when we're doing an R Markdown, the number of those will represent the level of heading, okay? And anytime you open a raw R Markdown, you get this little bit of information. This is an R Markdown document. R Markdown is a simple formatting syntax for authoring HTML, PDF, or MS documents. You can go to rmarkdown.rstudio.com for more details. And then it gives you this little bit of information. When you click the knit button, And this up here that shows the ball of yarn with the needle going into it, that's the knit icon. You can select the little drop down to the right of that. You can knit it to HTML. You can knit it to PDF, or you can knit it to Word. And I'll show you how to knit to Word. Sometimes PDF can be challenging to knit to if you don't have the proper programs installed on the machine that you're using. But if you knit to Word, you can also save that Word document as a PDF later, okay? So I'll show you mostly how to knit to Word today. But what it's telling you is when you do that, it will generate a document that has the content as well as the output and embedded R code in chunks within the document, okay? So this is a powerful way of sharing information and being very transparent about the code that was used to create output, because you can actually show the code and then show the output all in one document. And the way to do that, here's an example right here. So we're doing these two ticks. There's the curly bracket, and then the letter R, and then you can put other information in there. The bare minimum would be open the curly bracket, put the lowercase r in there, and then close it. But you can add information to yourself on top of that. Then we have summary of this cards that's loaded in the base package in R, okay? And then we close that chunk of code. And if you come over here to the right, there's a couple of options. You can either run all chunks of code that are above that all the way down to there, or the green arrow that looks like a play button is run the current chunk. And so what I'm going to do is just run the current chunk of code. And notice within our editing window up here and within the R console at the bottom, we get the same thing. This output from this new data frame that has more information about vehicles. I know we spent a lot of time talking about those early on in the semester. That just happens to be, I don't know if it's an American thing, we're obsessed with cars, but there's just a lot of data out there on cars. And so this one has only two columns, speed and distance, and those are continuous variables. So there's a minimum, a first quartile, a median, a mean, third quartile, and a max. And so we can just show a summary of the raw data within this document. And so it shows you what it might look like, and we can continue to scroll down. Notice that that chunk of code was closed. It puts the output after that chunk of code. Then we have a new second level heading here that says including plots. And it says you can also embed plots. And so for example, it has R again, pressure, which is just an annotation to ourselves that we're plotting data from this internal data set called pressure. And then notice there's this echo equals false. And there's a note there. So note that the echo equals false parameter was added to the code chunk to prevent printing the R code that generated the plot. There may be circumstances where you want to create a plot, but you don't want to show all of the code that went into making that plot. So maybe you're communicating some preliminary findings of your research to your PI or to your advisor, and you want to show a plot of the data, but you don't want to show the really complex ggplot code that was used to make that plot. You can do echo equals false so that it doesn't echo the code into the output, and it only shows the plot. So that's another option that might be of interest to you. So if I just run this chunk of code, we get a plot that shows temperature versus pressure. This is just some data that come in the base package in R. And this is a point plot using the base plot function that just shows the relationship between raising temperature and pressure. Okay, and we won't worry about interpreting those data. It's just solely for showing that you can embed a plot, and you can do it in a way that the code that was used to create the plot is not included. Okay, so that's just the very basics of how to put things into an R Markdown. If we go up here and do knit to Word, I'm just going to click on knit to Word. I'm going to save this. You can choose wherever you want to save it through this graphic user interface that comes up, this kind of point and click method. I'm just going to call that example and save it to the documents on this machine that I'm using to teach from. And then notice down here in this console, it switched to a new tab called R Markdown. And it's working on knitting that, okay? So it knitted that into a Word. Hopefully this pop-up screen, this Word document, is everyone on Zoom seeing this Word document that came up? Okay. And it shows the title, it shows the author, it shows the date, and then where we had those 2 pound signs and R Markdown, notice that's large and bolded. And then there's a sentence there that was included there. Then here's our chunk of code. It was only summary cars. And then here's the output from it. And then it says including plots. You can also embed plots. And so, for example, there's a plot there. But notice we don't have the little chunk of code above the plot that was used to make that plot because we did the echo equals false. So then you can just go view, we can edit the document. And notice now this is a Word document. And so, you know, you can edit the text further here if you're unhappy with the spelling or the way that the formatting looked like, the way it looked coming directly out of R Markdown. You can now use Word to edit that and then save that either as a Word document or a PDF, or any of the options that come with using Word, okay? So there's a very brief introduction to R Markdown. I had, for those that are taking this class, put online an example where I challenged you to create your own R Markdown document, read in from the ggplot2 package, the MPG data, and then to create a plot from that where you're just showing engine displacement versus city or highway, I think I said highway, fuel economy, do a scatter plot, and then color the points in that plot by the engine cylinder size. So a basic 3-dimensional plot that we worked on earlier in the semester. But importantly, you got to come up with the code on your own this time, because I have been just giving you the code, but this is kind of a pop quiz, if you will. Can you remember how to do ggplot? And I'll hang out here for the rest of the time to help you with this, but kind of challenge yourself to create a ggplot and then knit that thing into a Word document. And then as the thing that I'll grade the class on today, you know, just send me the knitted Word document. Okay, so I'll stop this. There we go.